first one. The first one is a really easy question. They say explain why hydrogen chloride is classified as a compound. So before we look into this answer of this question, we need to understand what that explain means. Now, every time you see the word explain, you will need to know that you need to be able to explain the why, the chemistry behind things. So in this case, what is the chemistry behind why hydrogen chloride is a compound? Yeah, I'm really losing my voice a little bit. Okay, so the why must be explained. So take a look at the marks. The marks is two marks. That means you need to give me 2 points here. So you need to be able to see that hydrogen chloride is made out of two different elements. One is hydrogen and one is chlorine. So linking back to the chemistry, the first reason is because hydrogen chloride contains two different types of element, and that will only get you the first mark. And compound, they don't mix together, they actually chemically combine together. Now, if you find that the word chemically combine is a little bit hard, the word chemically joined together will still get you the same marks. So whenever you see, the bottom line here is whenever you see the word explain, you do need to be able to justify, to be able to explain why in terms of chemistry. Okay, if you can take a look at this red color point over here, these are the common wordings that students tend to use, and they will get no marks for that particular point. Okay, so instead of using chemically combined iron within it, the idea here is that zinc is actually more reactive than iron. At this point of time, are you able to recall the reactivity series of metals? That reactivity series of metal is something that you will need to memorize for chemistry. Unfortunately, there's no shortcut for this. Okay, so the first point here, you need to state that zinc is actually more reactive than iron. And how do you know this? Really and truly, is you are able to recall the reactivity series from the top to the bottom. Okay, so the first one is do you still remember what's the first one? The first one is potassium. Second one is sodium. I'm going to write this down actually as you watch this video. And these two are actually from group 1. So the group 1 metals takes the top spots. Okay. Hi, Atina. And then we have our magnesium. Where's my calcium and magnesium from group 2, and then aluminum from group 3, and then now you see zinc and iron. That's not all. I actually have dot at the bottom. There's actually a slightly longer list to this, but here I just wrote onto zinc and iron to let you see that actually zinc is placed higher than iron in reactivity series, and therefore zinc is actually more reactive than iron. So if you are able to record this reactivity series, you will be able to write your first point, that zinc is higher in the reactivity series than iron, or zinc is more reactive than iron, would get you your first marks. Then the second mark needs you to talk about what's happening here. So in this case, if zinc is higher or more reactive than iron, then zinc will actually oxidize or react before iron. Okay, so the keywords, or rather the very specific key terms that we are looking out for, is either oxidizes or reacts. Okay, so what is this zinc actually going to react with? It's actually linked to the topic of rusting. This zinc is actually going to react with the oxygen and the water in the atmosphere instead of iron. So it prevents the ions from rusting. So the keywords that we need to look out for here is either oxidizes or reacts. I put a double tick above oxidize because that is a better word over reaction. That is very specific. Now again, looking at the yellow zone here, these are the common mistakes that students tend to make. Okay, so students, for second point, students tend to say, hence zinc will rust before iron. Now, every time you talk about any other metal beside iron rusting, you will get no marks, because the word rust is only tagged to iron, and the reason why is because rust is actually hydrated iron 3 oxide. Okay, so we use rusting only for iron, no other metals. If you want to talk about other metals, then not the easiest to explain. So what exactly do they want whenever you see the word describe as a command word? Describe actually is something really easy. You just need to give a count. You just need to write in a sequential manner. You just need to, basically, you can even put like in point form 1, then you list down, 2, then you list down, then 3 you list down. You don't actually need any justification. You don't need to explain the science behind it. It's almost like you're writing an instruction manual in this sense. You don't need to explain why the person needs to do that certain steps. Okay, so it's very systematic, it's very step-based, but there is no need for you to explain. There is this describe command word is essentially very different from an explanation question. Okay, so there we go. So I've highlighted you do not need to discuss the reason behind. Okay, so for the first question, it's linked to chromatography. We're just going to go to mine. Okay, describe how the student can use the chromatography to determine the RF value for dye C, the dye in ink C. Sorry about this. Okay, so this is a 2-mark question. Again, you just need to talk about the steps. Okay, no need to justify. So what do we want to do? Okay, so for this question here, if I were to go up to the chromatogram, which is the piece of paper that has all the ink spots on it, we're looking at C only. How do we find out the RF value of this ink C? So you look at C and ask yourself, how can I find the RF value here? So you will need to first measure the distance between the spots, this black color dot that I've highlighted in red, the distance between the spot to the start line as mentioned in the chromatogram already. Okay, so measure that distance. That's the first one, and usually this distance will be shorter than the overall distance traveled by the solvent. So the solvent front, it's if you take a look at the top words, okay, the solvent front is referring to the distance traveled by the solvent. Solvent here can either be water or it can be ethanol, really depends on the context. The best part about this question here is they have labeled what those two lines means. Sometimes they don't, so you need to know how to describe a chromatography question. Now I'm going to challenge you. If you really want, you can try out like a 5-mark question that I've write down here. At the end of the day, I'm going to show you this question again. How can you describe a chromatography questions? And then you can drop it on. You can DM me directly, and then I can mark for you. I'll be happy to mark for you. Okay. Recently, I tried this with my year 11, and eventually everybody get a sense of what are the key marking point. Okay. But that's really linking to the RF value, how we calculate RF value. Okay. So those are the two distances that we want to measure, and how do we describe them in this step-by-step manner. So the first mark goes into measure the distance between the start line to the solvent front. Now this is the maximum height traveled by the solvent. Okay, so the first point is measuring the maximum height traveled by the solvent. Then number 2 is you want to measure the distance traveled by the spot. Okay, so that's the smaller one where the C ink eventually stop. Okay, and you want to divide the distance moved by the spot over the total distance traveled by the solvent. So this is how we calculate RF value. Take note here, in this describe question, we didn't even discuss why we need to do certain steps, okay? Because describe question or descriptive question does not need you to justify. It's a really easy describe question, okay? Describe in terms of electrons what happens when magnesium atoms and chlorine atoms form magnesium chloride. Now, this describe questions needs you to talk about things in a systematic order. No need to explain the why behind it, okay? So the focus of this question here is you need to focus on the electrons, and they want you to talk about magnesium atom and chlorine atom. So this is actually what I would do. Actually, I will underline what they want me to focus on. And in fact, I will even label the two important things: magnesium, chlorine, and then I will even underline the word electrons. I'm not a fan of highlighting. I didn't want to change my pen or pencil or stuff like that when I'm doing my paper, so I just underline. Take note, it's a 3-mark question. That means you need 3 points here. So the first point here is to just focus on what will happen to the magnesium atoms when they become an ion in this case. So the magnesium actually loses electrons, whereas the chlorine gain electron, because magnesium is a metal and all metals loses their electrons to become positive ion, isn't it? But we do not need to talk about the reason why. So take note of that. We do not need to talk about the reason why in a describe question. Okay. And so, but just writing that magnesium loses electron, chlorine gain electron will get you 2 marks. Amazing, right? So how do you get the 3rd mark here? Again, we also need to focus. The focus here is on the electrons. So you just need to be specific. You just need to tell me how many electrons is magnesium losing, how many electrons is chlorine gaining, and you will get your third mark. Are you able to use your periodic table and tell me how many? I've written out the answer for you. Okay, magnesium has 2 valence electrons, so it's going to lose 2, whereas chlorine has space for 1 more electron because it's group 7, right? Just need 1 more to be stable. So that is how you get your third mark. The third mark is to just be specific in the number of electrons. Again, the questions ask you to focus on electrons, so by highlighting this, the question demand, there is no way for you to lose your mark here, isn't it? Okay? Hello, for those of you who have joined me and stay on, thank you very much. Okay,